Good morning class. In this lecture we will discuss the language of an automaton. So far we have discussed how a particular string will be processed by the automaton and when or which strings will be accepted or rejected by the automaton. So these two topics are covered in the previous lecture. In this lecture we will see that what do you mean by or what is a language of an automaton. So let's move to the next slide. So language of automaton is nothing but the set of all those strings that are accepted by the automaton. So there are some strings which are accepted by the automaton, whereas rest of the strings are rejected by the automaton. So language is nothing but set of those strings which are accepted by the automaton. So you will count only those strings which are accepted by the automaton. So for example, if input alphabet is 0, 1, then the sigma star will be set of all possible strings which are created with the help of either 0 or 1. So this is infinite set, that is you will have some more strings here. Fine. So this is the string of the length 0, whereas these two are the strings of the length 1. These 4, 1, 2, 3 and 4, these 4 are the strings of the length 2. Then you will have the strings of length 3, then you will have strings of length 4 and so on. So sigma star is set of all possible strings. So out of these all possible strings or the infinite number of strings, some strings will be accepted by the automaton, the machine, and rest of the strings will be rejected by the automaton. So the language will be set of those strings which are accepted by the automaton. So for example, if the automaton M is accepting only these two strings which are in the red color and other strings are rejected, then the language of the automaton will be 0, 0, 1, 1, that is these two strings only. Fine. So in the another language, if L is the next example, if L is 0, 1, 0, 0, 1, 0, 1, 1, 0 and 1, these 6 strings, then the automaton will accept only these strings, other strings will be rejected. If sigma is the input alphabet, then L is subset of the sigma star. It implies that the strings which you are counting in the language L must be selected from the sigma star or must be present in the sigma star. I am repeating, if sigma is the input alphabet, then L must be subset of sigma star. Its meaning is the elements of L, the language, must be present in sigma star. Let's understand this concept with the help of one more example. So you have to find out the language of the automaton if the condition given is number 1, if input alphabet is 0, 1, that is all strings will be made up of either 0 or 1. The automata is accepting all those strings W that starts with 0 and the length of the string is less than equal to 2. Sigma star, which is set of all possible string, is written here, and these are the strings which are starting with 0. This is the first string, then this string also is starting with 0, this string also is starting with 0, this string also starting with 0, but its length is 3, that's why we will not count it, this will be rejected. I am repeating, this string also or this string also are starting with 0, but their length is 3 and the condition is length should be less than equal to 2. That's why all these strings will be rejected. So only this string, this one and this one will be accepted because they are fulfilling the both conditions. The first condition is the string must start with 0 and length should be less than equal to 2. That's why, because the M is accepting only these 3 strings and other strings are rejected, that's why its language L will consist of these 3 strings 0, 00 and 01. So what is a language? Language is set of mathematical set of all those strings which are accepted by the automaton. Okay, let's take one more example. In this case, the input alphabet given is 0, 1 and the condition is string length should be less than equal to 2. There is no condition like the string is starting with 0 or the string is starting with 1. Here we have only one condition, and the condition is length of the string should be less than equal to 2. Whereas in previous case you have two conditions. The first condition is the string is starting with 0 and the length is equal to 2, less than equal to 2. But here in this question you have only one condition, and that is the string length should be less than equal to 2. This is the condition of acceptance. Those who are not fulfilling these conditions will be rejected. This is sigma star, that is set of all possible strings, and out of these strings only these strings which are in the red color are satisfying the condition whose length is less than equal to 2, that is length equal to 0, length equal to 1 and length equal to 2. So that's why the language of this automata will be these 6 strings, I think 6 or 7, 1 2 3 4 5 6 7 strings. So this will be language of this automata. Excuse me. In the last example, if the input alphabet is 0 1 and the automata is accepting those strings which are starting with 0, ending with 1 and the length is less than equal to 3. Here you are given 3 conditions. The first condition is the condition of acceptance. The automata will accept all those strings which are starting with 0, ending with 1 and the length is less than equal to 3. It implies that the string length could be 1, string length could be 0, it could be 1, 2 and 3, but not the 4. So these are set of all possible strings, that is a sigma star, and the first condition is string must start with 0 and end with 1. So this will not be selected because it's not starting with, it's starting with 0 but not ending with 1. This string will not be selected because it's not starting with 0. So this string is not ending with 1, that's why this also will not be selected. So this string will be selected or it will be accepted by the automaton because it's starting with 0, this is ending with 1 and its length is less than 3. Similarly, this will be rejected, this also will be rejected, this string will be rejected and this will be selected because this string is starting with 0, it's ending with 1 and its length is less than equal to 3. Fine. Similarly, this also will be accepted. Other strings will be rejected. The condition is string must start with 0, must end with 1. Whatever is the in between, leave it, but it must start with 0, end with 1, and the length should be less than equal to 3. That's why this language will contain only these 3 strings. So this is the language of this automaton. In other words or indirectly, you can say that if this is the language of the automaton, then the automata will accept only these 3 strings, other strings will be rejected. Now this is the assignment question, these are the assignment questions for you. In these 4 questions, what you have to do, you have to find out the language like this. You have to find out the language, that is collection of these strings which are accepted by the automaton. So what is different here, the first difference is, in this case or in these questions, the input alphabet given is A and B. In place of 0 and 1, the input alphabet given is A and B, and the conditions are more or like same. So in this case, the automaton will accept all those strings whose length is less than equal to 2. Whereas in the second question, the strings are starting with A because input alphabet is A and B. It implies that all these strings will be created or made up of either alphabet A or B. Fine. So these 2 characters will be used to create the alphabets, to create the strings. So this is the assignment question for you. So complete it. If you have any doubt, any question, please do write to me. I will try to explain or clear those doubts. In the next lecture, we will discuss how an automaton is designed or automaton, deterministic finite automaton is created. Till then, thank you very much.